Hi, welcome to the video demonstration of binary classifier SGD calibrated project 1 program for binary classifier. So again, similar to the previous chapters, we are using the same training dataset Yelp labeled .csv. So most of the program remains pretty much the same because the input data model classes and output data model classes are remaining the same. So again, let's look at the dependencies, and we can see under NuGet that we are using this project has already been updated to Microsoft ML version 1.2.0. If in your case you have not, then you need to update that again after the release of the sample software. If you find that Microsoft.ml package has been updated to version 1.5 or 2.0, make sure that you update your package. And in previous chapters, you've seen how to do that. So let's look at quickly the sentiment input data.cs file. It's again the same input sentiment input data class. We have load column 0, public string sentiment text. And the other property is load column 1, column name label, and public boolean sentiment. It's very similar, exactly the same that we have seen in the previous chapters. The output data model class sentiment prediction output is a subclass of sentiment input data, and we have three exactly the same three properties: prediction, probability, and score. And of course, you have to import the Microsoft.ml.data. So having looked at that, let's look at the program.cs file. Again, you import the usual libraries using system.io, and import the Microsoft ML libraries here, and Microsoft ML.data operations catalog library over here. So under the class program, again, you specify two paths. One is training data path and model path, and you have seen this before. Then you have declared the classify sentiment method. And then under classify sentiment, in step 2, you create the ML context object. In step 3, you create the training data view object using ML context data load from text file. And you pass training data path, hazard or false, a separator character, comma. Step 4, you instantiate train test data, ML context data dot train test split. And it takes the argument training data view and test fraction is 0.2. In step 5, you create the data preparation pipeline object using ML context transforms.text, featureize text, and output column is features, and input column name is name of input sentiment input data dot sentiment text. In step 6, you create the SGD calibrated trainer, and we use data preparation pipeline dot append, and we pass ML context dot binary classification dot trainers dot SGD calibrated, and we pass label column name label and feature column name features. And step 6, continuing step 6, we create the machine learning model called model SGD calibrated trainer dot fit, and we pass the train test data dot train set. In step 7, we create the iData view predictions for evaluation data view using model.transform method, and we pass train test data.test set. In step 8, we create the evaluation assessment matrix, calibrated binary classification matrix, and we use ML context binary classification to evaluate, and we pass predictions for evaluation data view and label column name label. Step 9, we create different assessment metrics: accuracy, F1 score, area under ROC curve, area under precision recall curve, log loss reduction, confusion matrix, positive precision, positive recall, negative precision, and negative recall. And you have seen this before, so I'm not spending too much time here. Again, in step 10, you create a sample sentiment text, and you can change the text if you want. In step 11, you create the prediction function, ML context model.create prediction engine, sentiment input data, sentiment prediction output, and we pass the machine learning model here as part of the argument. And using step 12, we create the prediction result and prediction function dot predict. We pass the sample sentiment text here, and then we write some console.writeLine statements to get the output. We have prediction sentence, predicted sentiment, and we have probability. And in step 14, we save the trained machine learning model, creating a file stream object and passing the model path, and using ML context model.save and passing model training data view.schema and file stream. So again, the programming remains fairly standard for the same dataset that we're using here. And so let's run the program and look at the output. As you can see in the output, binary classification trainer algorithm SGDCalibrated. We have the model quality accuracy 78%, F1 score 77%, area under ROC curve 85%, and under precision recall curve 83%. And we have the other metrics over here. As you can see, based on the accuracy and F1 score, this is slightly better or comparable to the earlier algorithms that you have seen in other chapters, but slightly better than the field error factorization machine algorithm. And here we pass the sentence, I love this restaurant, and the sentiment is positive, and it shows the probability is about 0.67. And the training model has been saved in the specified path. So this brings us to the output of the SGDCalibrated algorithm. Again, so far we have used binary classifiers to classify sentences into binary classes, two classes, one for positive, 0 for negative evaluation of restaurants on Yelp database or dataset. And so far you can see that we are using the same dataset, therefore most of the program has remained the same, and I have done this intentionally to make sure that you understand each of the steps, and that is fairly standard and straightforward to create machine learning models. And this is the binary classifier SGDCalibrated algorithm. We hope that you enjoyed the video discussion. Thanks for watching.